Hi everyone, this lesson goes over 3 ways to compare fractions. The first way we need to go over is called the benchmarks. So as you can see from these 2 examples, 2/3 is actually more than half, which is our benchmark. And 4/8 right here is actually less than half, because half of 9 should be 4.5. Since 4 is less than 4.5, 4/9 will be less than half, and that resulted in the fact that 2/3 is more than 4/9. In the next example, we will compare 4/5 with 36/45 by turning them into equivalent fractions with a common denominator. So let's first highlight the denominators in this case, the 5 and the 45. So in fractions, you normally look for a least common denominator or LCD. And you do it in the same way as if you're doing the LCM. So we take the 5 and the 45, we divide them using the division method. The only number that goes into them is 5, which brings the number down to 1 and 9. And since LCM means you're multiplying the numbers in the L shape, that brings us 45 as our common denominator, which is the LCD. So you want to turn this fraction to a denominator 45, and same thing to a denominator 45. So now let's see how fractions are converted. Going from 5 to 45, you will be multiplying by 9, and since we are doing a proportional relationship, the 4 will also be multiplied by 9, and that brings us 36. For this one, since the only way to turn a 45 to a 45 is timesing by 1, that means the 36 will also times 1, which you have the same thing. And as you can see from this example, the 2 fractions are equal, so the sign in between them should be equal. Now my favorite method of the 3 is the cross product. Let's begin by writing the numbers down, which is 7/9 and 14/17. Normally when you want to convert the numbers to the same LCD, you will first go through the division method and so on, but there's a trick to skip that step. So we're gonna just find the common denominator by multiplying 9 and 17 together, which again, we don't even need to know what the number is. I'll leave it blank. I'll explain to you why we don't need to know. For the 7/9, I'll be multiplying 17 and 17, and on the 14/17, I'll be multiplying by 9 and 9. Given that they are the same denominator, the only thing I need to find out is what's in the numerator, which brings 119 to the 7/9 and 126 to the 14/17. Given that the denominator is multiplying by the same number, they will be the same. So the only thing that matters to us is which one's bigger in the numerator. And as you can see, this is the bigger number. That means 14/17 is bigger. Just to make sure you understand this concept, let's try it with another example. Let's compare 5/8 with 7/11. Once again, the common denominator will be 8 times 11. That means 5/8 will be multiplied with 11 over 11. 7/11 will be multiplied with 8 and 8. And again, since they have the same denominator, we really don't need to find out what that equals to. All we need to care about is what is in the numerator, which 11 times 5 is 55, and 7 times 8 is 56. As you can see, 7/11 is the bigger fraction. So we will put in the less than sign right here, and you're done. Just want to make sure you notice this can be done quickly by cross multiplying, and let me circle that and show you. Notice how you're basically multiplying the 8 with the 7 and the 5 with the 11, so you don't really have to write the 2 side numbers right here. These are really not necessary to write down. I only wrote it to show you the concept. Okay, let's write down some facts. The first thing that you notice from these 2 examples is that we don't really need to find a denominator because they'll be the same through cross product. Now let's try this last example, which is negative fractions. As I have told you in the previous slide, we can actually skip writing the numbers. We should know that on the negative 6/8, you'll be multiplying with the 14, and on the negative 9/14, you'll be multiplying with the 8. So we're doing cross product right here, which gives me negative 84 and negative 72. Now these are supposed to be fractions, but given that I just want to have you understand how negative numbers are going to be on a number line. As you count backward to negative numbers right here, you should know that negative 72 should come before negative 84, which is closer to the 0. As you see the location of them on the number line, 72 is actually bigger because it's further to the right side or closer to the 0. That means in this question, the smaller negative number is actually bigger. Negative 914 is actually bigger. So to wrap this up, when you're comparing fractions, it's actually the smaller negative number that's bigger. That's it for the lesson.